Good afternoon, everyone. Welcome to our webinar titled The Perfect Seal Navigating Challenges in Line Pipe Flanges. Thank you for joining us as we uncover cutting edge techniques to combat corrosive media and permeation issues in demanding chemical environments, focusing on the critical role of flanges in sealing connections. Discover strategies to overcome challenges with non metallic flanges and unlock the key to superior sealing solutions. Before we start, I'm Rajesh, Erith's marketing manager. Erith stands as one of the fastest growing companies in the Middle East, specializing in sealing solutions, fire safety measures, and pipeline protection. Amidst recent accolades, our CEO has been recognized as GCC's Greatest Leader of the Year 23-24 and Most Influential Business Leader by renowned publications. Partnered with world-class manufacturers and service providers, Garlock Sealing Technologies, GPT Industries, Vimal Fire, ITW, we deliver top-notch solutions for various industries. I'm pleased to introduce today's speaker, Syed Hamza. Hamza, our dynamic applications engineer, bringing in a wealth of industry insights in addition to designing solutions and providing technical support for our inside sales team. Hamza actively conducts technical training sessions for site engineers, installers, and operators, and plays a key role in developing innovation and engineering roadmaps. Hamza holds a degree in mechanical engineering from Nagpur University, India, and Chennai, India is where Hamza is joining us from today. Before we proceed, here are 5 important points. Please feel free to ask any questions using the Q&A button at the top of your screen. We'll address your questions during the Q&A session at the end. If we run out of time, we'll follow up with you directly. Let's keep these things interactive so that it'll be a back and forth discussion between us with your questions. This session is being recorded and you'll receive a copy within the next few days. Interested in a professional development hour certificate from Erith, we'll provide that too. Thanks again for joining us, and without further ado, I will pass it over to Hamza.
Thank you, Rajesh. Hello and welcome to this webinar on navigating challenges in line pipe flanges. I'm Hamza, an applications engineer at Erith Group, and we'll just go right into it due to constraint of time. So I'll give you a walkthrough of the agenda that we have today. We are going to talk about line pipes and why are line pipes used. We'll be talking about the flange piping and lining materials and the different types of lining that are there, the polymer lining, the elastomeric lining, the glass lining which is done on pipes. We'll talk about the challenges that this type of lining poses to flange connections, and we'll talk about the solutions to those issues and challenges. So going ahead, we will talk about the advantages of these line pipes. So basically, the advantages depends a lot on the type of the liner that is being used for the piping system. But major advantages all throughout the board are the three major advantages: the chemical resistance, the permeation resistance, and the abrasion resistance that these type of lining provide for protecting the piping systems as well as walls on and flanges, all that are there throughout the piping system. So these three advantages we'll be talking about in detail later on in the presentation. First, let us understand the type of piping and flange material that we have that are available for lining with these type of liners. So basically, the type of piping and flange material can be divided into two types: the metallic ones and the non-metallic ones. The metallic ones are commonly seen throughout the stainless steel, different types of stainless steel that are used for piping systems, as well as carbon steel is also used. We have alternatively low strength metals like bronze and aluminum that are also utilized in some rare cases. Apart from that, we have non-metallic uh, piping and flange material. These are utilized for their greater corrosion resistance, basically. So the typical non-metallic lightweight piping and flanges can be in recent years we have seen fiber reinforced plastics, and it has been widely used in processes, whether it be water works or it be chemical industries. The FRPs are generally used due to their high resistance to corrosion. FRP pipes are also increasingly used for transportation of oil, fuel, water, glycol, wastewater, whether it be sewerage. As a result, the demand for FRP pipes is continuously increasing. The FRPs generally have a great service life, usually very high to the range of about 50 years. So does it kind of brings down the total cost of an FRP pipes, like in terms of the amount of time that they are going to be used in service. Based on that price, that their price, it becomes quite cheap. So this is increasingly being used. Another material for these non-metallic flanges are the glass reinforced epoxy ones. These belong to a group of fiber reinforced plastics. Like it is a composite material consisting of an epoxy resin used as a base polymer matrix and reinforced with glass fibers. GRE is widely used as an alternative to carbon steel, particularly in industrial pipelines due to its corrosion resistance, chemical resistance, due to its low thermal conductivity, and as with FRP, it is also very lightweight and because of its desirable mechanical properties. So the piping and flange materials can be divided into two: metallic, non-metallic. There are many different materials that comes under both. Now we go ahead and talk about the liner materials. So the lining inside the piping system can be done with any of these materials. We are classifying these into three major types. One is the polymers, another is the glass, and the elastomeric liners. So these are some of the common liner materials that are there. There are other liner materials also, and these are the major ones that we are talking about today. So polymers like polytetrafluoroethylene or your FEP, fluorinated ethylene propylene, as well as perfluoroalkyls. These are used for their immense corrosion resistance and their chemically inert properties are very helpful. They're used for lining containment vessels or tanks. Apart from piping, these are being used in diverse applications in the chemical processing industry to safely contain and distribute highly aggressive chemical compounds. Um, Again, glass has great sanitary advantages. It is glass lining is used in tanks as well as for piping systems. Um, uh, Again, elastomers. These are the elastomers like the natural rubber, the isoprene, and neoprene, as well as ethylene, propylene, diene monomers. These are all used in cases of majorly used in cases of abrasive slurries or when there is uh, chances of abrasive material being used in the media. These elastomers hold on really well in abrasive services. Going ahead, we'll talk about the first one, the polymer line flanges. So to seal a piping system that is lined with polymer, we have to we have to encounter the challenges that are there in holding flanges that are lined with polymer. So the polymer liners basically provide chemical resistance and permeation resistance. This type of liner is commonly found not only piping but also in flow meters. So we see cases where the piping system is not just connected to other piping system, but also to flow meters or in some cases valves. There are PTFE valves majorly used in severe chemical services. To in those cases, we do see these pipes connected with valves. Um, uh, Basically, these type of flanges, that typically is the liner stops inside the bolt circle and creates a raised face contact surface. Talking about the metallic ones, the advantages are based on the type of liner that is used, and we generally they are chemically resistant. The polymer lined flanges that are metallic are resistant to permeation. The distinct advantage of a metallic flange is that uh, a polymer lined metallic flange will prevent corrosion that is caused by the media it carries. So the metal which would have been attacked by the fluid, if it were used directly in a metallic piping system, uh, uh, this corrosion is prevented by the use of polymer lining inside metallic flanges. Now, talking about non-metallic flanges, like the metal flange versions, polymer-lined non-metallic piping and flanges are used for chemical resistance and their increased permeation resistance. However, the non-metallic piping and flanges, which are typically FRPs, have much lower allowable torque values. So, as we can see, the chemical resistance and the resistance to permeation is common among both. However, non-metallic flanges have a distinct advantage that they eliminate corrosion due to the harsh environment outside. They protect it from the elements. The recent UV-resistant models of FRPs are even resistant to sunlight, so that gives it a all-rounded protection from the environment, as well as they are very inert, so in the sense that they do not easily uh, form chemical reactions. So they're chemically resistant to the media as well as to the environment. So they have added advantages. Other advantages that non-metallic flanges that are lined with polymer bring to the table is that they have reduced weight. So they have a less weight. They are electrically insulating, and since they are non-metallic, they reduce the noises caused due to vibration and other system processes. Generally speaking, in most cases, the liner inside the pipe extends up and across the face of the flanges and either stops inside the bolt circle of the flange, simulating a raised face flange contact area, or extends all the way throughout to the outer diameter of the flange and has bolt holes. So these are the two types of flanges that we'll see with the polymer lined configuration. Going ahead, we'll talk about the elastomer lined flanges. These type of flanges are excellent in abrasion resistance. Elastomer or rubber lining can provide chemical and permeation resistance as well as added advantages. The other more common reason for this type of liner is the abrasion resistance in industries like mining, where slurries are prevalent. So the rubber lining often stops inside the bolt circle as well, creating a raised face contact area. In addition, the rubber used for the lining is typically lower durometer rubber, like below 80 shore hardness, and it is very common for these flanges to be assembled without a gasket. Now that being said, there are customers that do require gaskets. The reason being they likely had problems with the liners sticking together and tearing when the connection was opened up. At one point or the other, yeah, the connections are going to be opened up, and this is a challenge that is continually faced in rubber line, elastomer line flanges. The challenge then becomes selecting a gasket like that will prevent sticking and tearing. Again, um, many polymer and rubber-lined pipe manufacturers recommend assembling the flanges without a gasket, sealing one liner against the other. The gaskets are typically recommended for these line pipes mated to if they are mated to a valve or to a line pipe flange, or if a joint is opened and reassembled. Yeah, these are the three major cases where an elastomer line flange will require a gasket, even though the manufacturers have said that they can simply uh, make a flange connection without using a gasket. But that is just for the first time. In every repetitive turnaround or flange connection being opened, you will have the issue of the liner sticking and tearing off. So that will require a gasket to be placed there also. So now talking about the last one, the glass line flanges. The glass lining is commonly used for chemical and permeation resistance in the chemical, food and pharmaceutical industries. The major advantages that comes with the lining a piping system with glass is the smooth and impervious nature of the glass lining, and it makes it an ideal choice for piping and equipment used for manufacturing batches of products, where you have a line that is not in continuous use, but it might have a batch production, and in which you have the media flowing through it, and there are moments where the media is not flowing through it, and that requires a decontamination or cleaning of the batch. As the glass surface is very smooth and impervious in nature, it is very easy and quick to clean and decontaminate these type of piping systems that are lined with glass flanges. These prevent corrosion caused by the media it carries, since the glass does not easily react with the chemicals. Now, going ahead and talking about the challenges that are faced in these type of lined flanges, the polymer, the elastomer, as well as the glass lined flanges. So, talking about the lined metallic flanges, gaskets or flanges with this type of liner need to provide comparable chemical resistance to that of the liner. So basically, the liner that is chosen for the severe chemical service. If you're putting in a gasket that cannot handle the severe chemical service, there's no point in putting it in a uh, piping system. The gasket also needs to be soft enough to avoid compressing the liner and easily sealed as well. As these flanges typically have low allowable torques, so we have to keep in mind, once assembled, the connection now has two sources of relaxation because of the liners on each flange along with the gasket. They are in compression. So again, we have the liner as well as the gasket. These two have to be considered when taking into account the allowable torque, as well as the relaxations that are going to be there in the flange connection. So it goes without saying that retorquing before starting up is highly recommended, since they have additional sources of flange relaxation. Now talking about challenges faced in our non-metallic lined pipes. Yeah. So basically, in non-metallic line pipes, the major hurdle that we face is a hurdle that is faced in creating and generating enough load for traditional gaskets. So traditional gaskets require higher bolting loads, higher gasket stresses. Uh, that is very difficult to do with non-metallic pipes due to their reduced strength. And if we do use the kind of this common gaskets, maybe a aramid type gaskets or other gaskets, they can cause cracking of the lightweight flanges, whether it be FRP or GRE. Again, another issue that we come up in these type of non-metallic line flanges is the issue of permeation that comes with FRP flanges. We have delamination of the multi-piece design. That is, the leak paths are created through between the laminates of the different uh, uh, the, basically the fiber reinforced plastic material itself. And we have issues where we have foldovers of those envelopes. Uh, Again, talking about the bolt loads that are available, we have extremely bolt loads available. As you can see, multiple examples where we have of about 50 foot-pounds of a torque values, a maximum torque value that is recommended for this kind of flange. Somewhere around 20 to 30 foot-pounds of torque value that is given. 30 foot-pounds, as we can see in this glass reinforced epoxy flange. So we have very low bolt torques. A common aramid gasket, for example, requires at least a 120 foot-pounds of, generally speaking, or 20 foot-pounds of torque in these type of similar flanges of similar size. So as comparing with FRP and GRE flanges, this is extremely low. So uh, now we'll talk about the challenges faced in glass line flanges. So basically, a glass line flanges, like, the lining has its challenges. Not only is the glass brittle and easily damaged, the allowable torque will while not as low as the polymer or rubber lined flanges, but still the allowable torque tends to be less than ideal. In addition, the sealing surfaces, which are usually stub end, as you can see on the right side on the in the diagram, the stub end has the slip-on flange. It creates a raised face contact area that tends to be very smooth, and in some cases even uneven, basically, or wavy because of the glass lining. Due to the process that is involved in glass lining, this is mostly the case where these edges are not entirely even, and this creates another hurdle and another challenge. Therefore, the sealing solution for this type of flange has to be very compressible as well as conformable, while being resistant to the process fluid and able to seal at lower stresses. So there's a huge challenge in a flange that is lined with glass. So now going ahead, we have talked about the types of flanges, the liners for the flanges. We've talked about the challenges that are faced in these types of lined flanges. Now going ahead, we talk about the solutions for these kind of lined flanges, and here we have the stress saver gaskets. In many cases, the stress saver is the type of gasket that is best option for these connections, as these gaskets are designed to seal at extremely low available assembly stresses that can be generated in these type of flanges. It The stress saver is a type of gasket that can solve low load sealing issues, and there are different models based on the material of construction. We have the floor elastomer models, we have the EPDM model, we have the PTFE model, and how basically how the stress saver works is that it has a molded in sealing ring that creates 75% less surface area for high performance in non-metallic flanges. Again, it has low seating stress due to the reduced area, and we can use the specialty PTFE gasket, and these can be used in both raised face as well as full face flanges. The contact area is reduced by 75%, as you can see in the diagram. The ribs cause the reduction in the contact surface area, and the PTFE envelope over the ribs in the material of the gasket. Generally, the gasket thickness is about 1/8 of an inch, and we have these convex sealing rings that provide increased recovery of the gasket while it is placed under flange. We have the Gylon 3504 and the Gylon 3505 stress saver gaskets. These are made out of the Garlock's proven PTFE range of Gylon gaskets. The Gylon 3504 is the blue Gylon, which is ideal for many different chemicals, as well as it is ideal for potable water. The rib design gives an advantage of low load of sealing, and the both styles, 3504 and 3505, they meet FDA and USP class 4 requirements. For water service, we have recommend style 3504, which has NSF 61 certifications. And these are available for all throughout 1 inch to 8 inch of pressure and of nominal pipe size, as well as pressure class of 150. Going ahead, we talk about the different stress saver models that we have. Uh, as I said, 3504 Gylon is capable of handling medias like solvents and most caustics and acids that are seen in service. It can handle hydrocarbons, waters, refrigerants, cryogenics, as well as as we have seen, it has an NSF 61 certification for potable water. We do have a fluoroelastomer, a proprietary blend of fluoroelastomer gasket with by the name of style XP stress saver. Again, we have rubber models, which is EPDM model stress saver. Also, we do have 100% pure PTFE bonded to EPDM model, that is the style 370. These gaskets generally go from 150 degrees Celsius maximum operating temperatures to 260 degrees Celsius of maximum operating temperatures. Yeah, and pressures can range from 250 up to 300 800 pressure psi gauge. So we have done a lot of testing on these type of gaskets. Let's talk about one of those tests. Here we have taken an FRP pipe flange with lubricated carbon steel bolts for this type of flange arrangement. This with a nominal pipe size of 6 inches. The temperature here was set at from 95 to 180 degree Fahrenheit. It was cycled throughout this temperature range. The media being the water and held at a pressure of 150 psi. The recommended for these type of flanges, the recommended torque for this now by the manufacturer themselves was 35 foot-pounds, and it was based on that requirement. It was torqued up to 35 foot-pounds. And went through cycles like a 30-minute ramp up of temperature up to from 95 degree Fahrenheit up to 180 degree Fahrenheit. Then at a 5-minute dwell at that 180 degree Fahrenheit temperature, then a cool down period of 10 minutes down to 95 degree Fahrenheit. So this controlled testing of this model showed no signs of leakage when installed between FRP flanges. The flange assembly has been subjected to over 3,500 thermal cycles without a need for any retorque. So these are the stringent in-house testing that we have done, but we do have our customers that have utilized this stress saver gasket in their own plants, and they have an amazing response from them also. So here we have a chemical plant that has utilized FRP pipes and flanges to supply and discharge brine for the electrolysis process for obtaining chlorine. So this chlorine plant had a media of brine with a temperature of 160 degree Fahrenheit, the max one, and the size of the flanges were 4-inch nominal pipe size at a pressure of 100 at a 150 pressure class FRP, a flat face flange. These you were using are blue Gylon stress saver gaskets, and they had been in service of 2 years or more, and it's an old one, so like it is more than 2 years that they have been in service without any issues. The basic expanded PTFE gaskets typically weaved over time, but when they have been using our Gylon stress saver gaskets, they are having good results. So another solution for these type of gaskets is the Gylon EPIX models. Gylon EPIX model is have a patented design, and they are provided with a hexagonal raised surface profile. So they are made with the same proven PTFE material of the traditional Gylon gaskets from Garlock, and they are provided with different sheet sizes as well. These type of gaskets work quite differently based as compared to other gaskets since they have a pressure sensitive film. This is a stress quantified diagram where you can see a Gylon a glass filled PTFE as compared to a Gylon EPIX model. This is a 3504 Gylon EPIX model that we were talking about. Here, as you can see on the left, there's stress concentrations, whereas there are regions where the stress is not the bolt stresses is not uniformly transferred all throughout the gasket, and we see areas of higher stress concentration and areas of lower stress concentration. This example is from a 3-inch nominal pipe size and a pressure class of 150 full face flange, which was torqued up to 120 foot-pounds. As you can see, on the right hand side, you have the Gylon Epix model. Due to its pressure sensitive film and the hexagonal profile structure on the surface, we see an even distribution of the bolt loads and the gaskets, which is transformed into the uniform gasket stress all throughout the surface of the gasket. Uh, uh, Again, this is without the pressure gradient. The same 3-inch pressure class 150 flat face flange. You can see the comparable values of stresses on the left side and the right side, as you have the Gylon Epix model, which has even distribution of the pressure. So Gylon Epix model, they simplify your gasket requirements, and they have superior performance. They are great at sealability. They have good blowout resistance, and the major requirement of an FRP flange is the bolt load retention and sealing under low bolt loads. For this, a thinner gasket is of Gylon Epix can be can be provided as a thinner gasket, which can conform as well as is work perfectly under FRP flanges. Yeah, it also works well with worn or pitted or misaligned flanges. It has improved performance due to improved compressibility over traditional PTFE gasketing material. Again, as I talked about simplification and the reduction of inventory and stocking issues that comes with having multiple gaskets for different types of flanges, different types of flange connections. Um, uh, that can be eliminated with Gylon Epix models. They have a huge range of bolt loads that they can handle and conform to the surfaces of different types of flanges, whether it be damaged flanges or whether it be wavy and uneven flanges. The Gylon Epix models are well capable of sealing under those situations. Um, Talking about Gylon style 3545. This is this is an FDA compliant PTFE gasket made of microcellular PTFE with a rigid PTFE core in the center. So this provides added advantage in when you're using glass lined flanges, since the microcellular PTFE is highly compressible. And these outer microcellular PTFE layers get compressed under low bolt loads and seal between the glass lined flanges, as well as the rigid PTFE core reduces the cold flow and creep now that is associated with conventional PTFE gaskets. So this Gylon style 3545 is a best fit for glass lined flanges. This is added with the excellent chemical compatibility of pure PTFE. The Basically the glass line flanges are being used in severe chemical services, right? And the gasket needs to conform to those standards of chemical service. And since the style 3545 is made out of pure PTFE, it we can withstand a wide range of chemicals. And apart from that, the added advantages of using this style of Gylon is that the soft PTFE can be easily cut out from larger sheets, and reducing the inventory costs and expensive downtimes, as well as it allows for field cutting of these gaskets. So that reduces the amount of time that is wasted in getting a cut gasket ordered and brought to the site. Apart from that, the rigid PTFE core facilitates installation even on larger diameters flanges and different hard to reach areas. So based on the gaskets that we have talked about, we can recommend solutions for different polymer line flanges. So talking about the metallic flanges in general, with polymer lined pipe flanges, or whether it be polymer lined gauges, meters, or polymer lined valves, the Gylon 3545 is the product most frequently recommended as it provides excellent chemical resistance. It is highly compressible and seals at lower stresses. Also, in most cases, the flange connections are pressure class 150 or 300 pressure class. That's generally the case with these type of flanges. Now, with non-metallic gaskets such as Gylon 35454, they are suitable for. If higher pressure classes are encountered, you can get back to us and we can work out a solution for you. Talking about the non-metallic flanges. So in many cases, a stress saver type gasket is the best option for these connections, as these gaskets are designed to seal at extremely low available assembly stresses that are generated in FRP in flanges. It is important to confirm that the torques do not exceed the maximum stress recommendations for while using rubber stress saver gaskets. We do have fluoroelastomer as well as EPDM bonded with PTFE stress saver gaskets, as well as pure PTFE as well as PTFE stress saver gaskets. So another gasket that we can use in polymer line flanges of non-metallic polymer line flanges is the Garon Epix model. As the liner material is, if the liner material is rigid enough and the flange surfaces are smooth, getting the maximum allowable torque values from the flange manufacturer, you can use these type of gaskets also easily. Talking about elastomer lined flanges, we believe the best solution to this challenge is a thinner gasket, like a 1/32 1 over 32 inch or a 1 over 64 inch gasket made out of Gylon style 3522. The style 3522 material has very good permeation resistance, and when it is kept thin, it minimizes the amount of outward force that can be generated at the inner edges by the system pressure. Also, the style 3522 is pure PTFE, so it provides exceptional chemical resistance, and it will not stick to the rubber lining on the flange faces. As with polymer line flanges, if the flange class over 300 are encountered, you can contact Erith and we can work with Garlock for your requirements. Talking about the glass line flanges, historically customers have reported great success with Gylon 3545 as well as the blue Gylon 3504, as these products provide the level of conformity needed to seal these smooth and sometimes uneven flange surfaces. Gylon Epix is also worth considering as well, as these products provide the proven performance of traditional Gylon styles with as much as 10 times the improvement in compressibility, which is key with these glass lines surfaces. Uh, as I talked about certifications, we have all these gaskets do have ABS certifications, and we talk about Gylon. So the Gylon has FDA approvals. It has NSF. Some, as we talked about some of the models, they do have NSF 61 certification for use in potable water. The required models can also have US Department of Agriculture approvals, and there are many other approvals as well. That can be the certification can be provided as with along with the gaskets. This concludes the solutions that we do have for FRP and GRE line flanges. If you do have any questions, feel free to ask them now. And we have covered the sealing solutions in as brief a manner as possible. This entire FRP, GRE line flanges, and different types of materials, the different lining materials. It is a huge segment. It is a huge field. We can talk about it in length. Feel free to contact me personally. And if you want to know about more about these type of gaskets, these type of flanges and their solutions, I'll be happy to get back to you on this. If there are any questions, please feel free to ask them in the box, and I'll be waiting for your questions. Please use the question and answer segment that is provided on the top of the screen to ask your questions. Okay, we do have a question. Uh, uh, okay, yeah, uh, perfect question. So we are being asked that is it possible to recommend non-asbestos gaskets for stress saver flanges? So when we are saying non-asbestos, it is mostly either aramid fibers, a gasket made up of aramid fibers with different types of binders, or it can be any of the proprietary material of fibers. These gaskets generally have very high minimum torque recommended for putting it into these flanges. And as we talked about the line flanges and line piping systems, the allowable stresses, gasket stress, as well as the allowable torques are extremely low. So the non-asbestos gaskets uh, for lower stress flanges is not recommended. That's it's one of the major reasons there is a shift towards the PTFE gaskets and other materials that we have talked about. Uh, yeah. So if you do put a non-asbestos fibers, they're going to have issues. Yes, absolutely. It's a nice question. Do we have comparison chart between each type of non-metallic flange gaskets related to their water absorption and also for the permeation of gases? We do have those test values for the gaskets, and these values for water absorption as well as the permeation of gases. So gas permeability is available with the data sheets that we provide for these gaskets. These are freely available. You can get back to me and I can provide you those data and those values and the tables for those. It is very easy to compare your different types of gasket possible options based on the gas permeability as well as water absorption. Um, uh, from the top of my head, as I can recall, we have, if we talk about Gylon, blue Gylon style 3504, for example, um, the, the gas permeability for such a model is like within 0.0005 milligrams per meter second. So these tests are based on the European standards, the DIN 3535-6. So talking about the gas permeability in these type of models, it is extremely low. So as you can see, it's like 5 to the exponential of -4 milligrams per meter second. That's just talking about the blue Gylon 3504, and yeah. So these type of gaskets, we have all the permeation gas permeability values for almost all the models. And if you can get back to me, I can get in touch with you. And yeah, with every gasket that we provide, we will be giving these values. Okay. Yes. A great question. Another great question that has come up here is that the gasket indicated here, gaskets indicated here are all full face gaskets. How do they fit in raised face polymer line flanges in terms of sealing? Are additional spacers at bolts required for such flange joints to ensure proper sealing? No, actually, the gaskets that are shown here as full face gaskets. We do have gaskets. Basically, raised faces increase the amount of they reduce the amount of area for the ceiling, and thereby it increases the bolts the gasket stress. So in this case, uh, when we have flanges that are that cannot have higher bolt loads, that cannot have higher gasket stresses. So these generally do not have uh, a requirement for either like or how do I put it? The race-faced flanges uh, uh, will require a gasket that needs a higher gasket stress, and what we are dealing here are extremely low gasket stresses. So these gaskets invariably have the capacity to work in race-faced flanges, as well as they can also be used in full-face flanges. I hope that answers the question. Yes, yes. Okay, I'll elaborate on the previous question. This question regarding the non-use of non-asbestos gasket in these type of flanges. So basically, asbestos gaskets, non-asbestos gaskets that we're talking about, it can be compressed non-asbestos fiber that we're talking about here. And these compressed gaskets have a very high gasket stress, that is minimum gasket stress that is required to make a perfect seal. And these type of stresses cannot be attained in FRP flanges as or GRE flanges or non-metallic flanges that are lined with polymers. So, due to the inability of torquing up these flanges to such a higher bolt loads that is required for these type of flanges, these type of gaskets to seal, we do not recommend putting compressed non-asbestos fiber gaskets in non-metallic flanges. Okay, I think I hope I have answered all your questions, and we'd like to go ahead and end this seminar and this webinar. Thank you all for joining in for this webinar. And if you have any questions, please feel free to ask me through the mail. You will be having my details as well as so this webinar basically will be forwarded to you. A recording of this will be forwarded to you, and you'll have my details with that also. We hope for a safe, effective, and economical operation of your installations and facilities. Thank you for joining this webinar. As I said, a recording of the webinar will be sent to you shortly. We hope to see you again soon in the next one. Bye-bye for now. Thank you.